So we are going to talk about asynchronous behavior. And the reason is not that it is great or that I think you need to know this in JavaScript, but because you're going to run across it. And I mainly want to show you how to survive it. It's not a necessarily easy topic, but for example, if you would want to use the new scripting environment in Switch, then you're lost already. That is Node.js based, and there is lots of asynchronous stuff going on. They hide most of it, luckily. And I'll show you how to hide it in other environments as well. If you want to do something with Node.js, you want to make a website, if you want to work with databases, in all those cases, asynchronous behavior is unavoidable. You have to do something with it. Fortunately, you can turn most of it off or, like I said, hide it, so it doesn't have to bother you all that much. Okay, so let's start by what we do know, which is synchronous behavior. Everything we've done in this series of JavaScript cafes so far was synchronous JavaScript. And it looks like this. We use this for something else. We use this when we're explaining workflows, and we are going to do this from A to Z. But it's actually exactly what synchronous programming is. You start at A, and then you go to B, and then you go to C. There are no interruptions, no branches into some other direction in the middle. It just follows the flow of the JavaScript code that you write. So that is what we've been doing so far, and it's very, very easy, one line after the other. And you could wonder why you need something more than that. Well, the problem is, if you start doing stuff with Node.js, and we have done stuff with Node.js because we've been using it in the previous cafes, then you can still do synchronous JavaScript. Node.js essentially is single-threaded, but Node.js very often operates in environments where it has to do stuff asynchronously, working with an API, talking to a website, talking to a database. All of these things are normally things that you try to do as asynchronously as possible because they can take a long time. It's difficult to predict how long they will take. There are things like latencies to take into account and so on. So it's good to just post a task and then have it done in parallel to your main business. And that is what essentially asynchronous coding comes down to. You want to be able to do multiple things at the same time, and then when they are done, you want to do something with the result. So why? Well, this is a very simple example of something that is synchronous. I'm going to make a function call, and it's going to take a very long time, and then I want to do something else. There's nothing magical going on here. I am going to start at the top, and I'm going to stop at where it says end. And each of these things is going to happen synchronously. What if I want to do two very long tasks, and then I want to do something with the result of these two things? If you run this synchronously, that means that you're going to do very long task number one, and then very long task number two, and then you have a chance to use both results. If you could do this in such a way that these long tasks you have run in parallel, then you could potentially save a lot of time. And this is why this asynchronous stuff in Node.js was invented, because in many cases, you want to be able to do this. Okay, so much for the presentation. I have more slides in there, but I'm not going to show them to you. Bear with me for a second. I'm going to stop my share, and now I'm going to share just the code window that I have, which should make it easier to follow there. So if all goes well, you should see, sorry, I will try not to change the size of it, but you should see Visual Studio Code. And if you remember that from the earlier JavaScript stuff we've done, is I'm going to do stuff here. I'm going to write actual code, and I'm going to give you the chance to follow along. Yeah? If you followed the previous ones, then you should have Node.js installed. If you don't, then you can go, well, Google Node.js. There you'll end up on a website where there is an installer, run the installer, and then you should be ready to follow along with us. So what I want to do is I'm going to build a very small example. And that example is going to allow me to show the difference between synchronous and then the same thing asynchronously. And then we're going to see 3 different ways of doing asynchronous code, hopefully in progressing steps of having less of a headache. So we're going to start by what is the original thing, which I think is relatively difficult to deal with in real projects. And we're going to go to something that is manageable. That's the goal. If you want to follow along, what you need is a folder on your disk. Mine is called session 8, which tells you that this is the 8th JavaScript session we've done. So I just created a folder and I dragged that into Visual Studio Code. You don't need to use Visual Studio Code. I just think it's great. So I'm going to use it here, but you can certainly do this with something else as well. And in this folder that I have, I want that to be a Node.js project. Now, if you still remember how to do that, that would be absolutely fantastic, but I'm betting that many people will not. So what you can do is right-click on this folder view here, and I can say open an integrated terminal, and that is going to give me this nice terminal window here at the bottom. And I can then do something like, well, if my typing would work, I can type npm init, and npm init, if you remember, initializes this folder that I am in, and I am in this session 8 folder. It initializes that folder as a Node.js project. In order to do so, it's going to ask me a bunch of questions, but I'm essentially not interested. So I'm just going to do enter on all of them and accept all the defaults. And if I do that long enough, it's going to ask me, this is what I'm going to do. Is that okay? And then I can say yes. And that is going to give me an Node.js project. And now I have this thing in here that is called package.json, which is the Node.js package description file. And that shows you all the defaults basically that we have added in there. I want to do one more housekeeping thing, which we've always done in the previous sessions as well. And that is that I want to install NodeMon. I'm not actually going to do it because at some point I installed it globally, so I don't need to. But if you need to do that, then you can do npm install NodeMon. And just run that. You can also install it as a development link if you want, but you don't have to. So I'm not going to run this command because I've done that in the past and I have NodeMon available wherever I want it. But if you don't, then you can do that. So other bit of setup is that I'm going to make myself a dev command. Okay, let me see, dev. And then what do I want that to do? I want that to call NodeMon and then index.js. Short reminder, these scripts that I have here will allow me to very quickly run a task in my project. And NodeMon will keep code, well, it will watch the folder that we're in basically. And then it will run one of the scripts that we have in that folder. And you might notice that we don't have that script yet. So I'm going to save this package file. And then Visual Studio Code gives me a very quick way of creating a file. And you have this little file plus icon. So I can do that and say index.js. And that gives me an index.js file, and there we could write something. So console, and I'm going to do something that we'll use in a second. So far, most of the time I've used console.log, which writes something to my console window. I'm going to use something else now. I'm going to use console time, and that will basically tell the console that it needs to remember a timestamp. Which timestamp? Well, there is an ID for that timestamp, and that is what I typed here, read file synchronously. And if I make a timestamp, it's probably to figure out afterwards how long something took. So I want to do that as well. Time log, another console function, and there I just give it the same key. So now the console knows here I am supposed to remember the time, and then when I run time log, I am supposed to see how long ago that was, and then write that out to the console window as well. Okay. And we're going to use that in a second to figure out how long it takes for certain things to happen, and to see the difference between synchronous and asynchronous if you want. So we're almost there. I have an index file, so that is good. I have a package file, that's also good. So we know that we are in a Node.js project folder. However, I don't have all my dependencies yet. I haven't really installed anything. So in order to do that, I have to use another npm command, and that is npm install. So init confirms that folder or converts that folder into a Node.js project. Npm install makes sure that all the packages that I want are set up. And if you run that, you'll see that there is now a package lock.json, which is internally used by Node.js to keep track of what is going on. But it hasn't actually given me a Node modules folder because we're using no modules, but we should now have a fully working Node.js project folder. How do we test that? Well, remember in this package JSON, I added a dev command, and if I did that correctly, I can say something like npm run dev. And if you've done everything correctly, then it is going to start nodemon. That is what that dev command was supposed to do, start nodemon. Nodemon is going to monitor my folder. Every time in the script here, every time I change something and then I do save, nodemon is automatically going to run the script that I have. So that makes it very simple to make changes and see what happens. Also notice that it does give me a time readout, which is basically what we've set up. So the elapsed time between when I make my timestamp and I then write it to the console is 0.08 milliseconds. That is not a lot of time. And we'll see that increase as we do some actual code. Okay, so we're all set up. That's a good thing. Let's do some stuff. I'm going to use file reading to start talking about this synchronous stuff. And if we want to do file reading in Node, there is a built-in Node module that is very useful, and that is that module is called file system. And it is shortened because otherwise it would be too simple. And it's called FS from file system. If we want to use that, then we can simply import it into our project. So I'm going to define a variable, and I'm going to say require, and then the module I want to require is FS. And I don't really need to do anything else because FS is an internal Node module, so I don't need to install it or anything like that. It is always there, and simply requiring it and assigning it to a variable is enough to be able to use it afterwards. And if I do save, you'll see that that still works. Nothing extra happens because I've included it. I've not used it, so that's normal. I want to read a file, and I'm going to use the same file creation thing here to very quickly give me a small file to read. So make something else. We'll call that test.txt. that gives me a text file, and then I can give that some content. You don't have to write something about penguins. You can write whatever you want. It just has to have something in it. Yeah? Okay, so how do I read a file? Well, what you would need to do in real life is you would need to go on the internet and look for the FS module, and then you will get the overview of all the functionality you have there. I can make that shorter, and I can say you can read a file by using an FS function. And you could imagine that it will start with read, and my completion here already gives me some possibilities. Now, what you can see is that for the file system module, the default way of working is asynchronously. If I would use read file, I would get an asynchronous function. And I want to start with a synchronous function. So I'm going to use the read file sync variant. Yeah. And what does it want? Well, it wants to know which file, which is easy. That's this test.txt thing that I've just created. And if we're good, we're also going to tell it what the encoding is that that file uses. What encoding is this? Well, in my Visual Studio Code, as you can see here at the bottom, by default, it's going to be UTF-8. So this file is Unicode. That's all we have to do. And then I could say console log or info or whatever. Log and info are actually synonyms of each other, and content. So let's see how successful we are in what we're doing here. When I run that, it tells me the content of that file, and then it tells me that the time that elapsed is now 7.36 milliseconds, which is still a very small amount of time, but it's maybe worthwhile to notice that we actually increased the necessary time by 2 orders of magnitude. We went from 0.0 something to 7.3. So reading a time is expensive. This is a very small file, but it's expensive to read it. And it's probably also expensive to write it out to the console afterwards. So, but we get this done. Yeah. This is, as I said before, synchronous processing. I start somewhere, then I read everything in that file. Nothing else happens while this file is read. If this is a 2 gig file, it will take a long time to read it, but it doesn't matter. The next line, line 5, is not going to happen until line 4 has completely terminated. Yeah, so it's synchronous, each line at a time and in the order that they are written. Okay, so let's do something that is more fun. Let's say that we want to do this asynchronously because this file might become a little bit bigger. Well, I'm going to set me up some stuff here. Let's comment this out so that we don't get overwhelmed by stuff on the at the bottom here. And now we're going to read it asynchronously. So I'm going to adjust my the name of this timer. And I'm only doing that because the name of the timer is also what is written out to the console. So I don't want to confuse myself. And we're going to do the same thing. I'm going to read something, but now synchronously using the file system. And this time I'm going to use, where is it? Read file. I'm going to use the asynchronous version. Now, you can see that I'm not preparing myself to get a result here as I was doing for the synchronous way. Why is that? Well, it is because I need to give something else now. I still need to pass the path to the file that I want to read, and I still can pass the encoding, but then there is the expectation that I also pass a callback, and a callback is a function. So basically, this read file function that I'm calling expects 3 pieces of information. My file that I want to read, just as before, the UTF-8 indicator, just as before, that says what encoding this is. And now I need a callback file. So we're going to call this read file done. I can give it whatever name I want. But this is supposed to be a function. So if I want to run this, I need to define that function. I need to say, well, let me define it. It expects 2 things, and this is very typical in Node.js, and it's something that you'll see in most of the Node.js calls that use callbacks, is that the first argument that you will receive in this file is an error object, and the second argument is a data object. And the idea is that if there is an error, then error will have something. If there is no error, then this will be undefined or null, and then you know that you can use the data object. So this is a convention that is used throughout Node.js in many places. I will add 1 additional line here, and then I will explain what is happening. So, well, actually, I need to add more than 1 line if I'm doing it correctly. So let's do what I just said. If we have an error object, then we know that there was an error, and there is a log console function to write that out in a neat way. So we'll do that. And if there is no error, then we're going to write out the content, except that the content is now this data thing. There. What is happening here? This looks much more complex, and that's because it is. Yeah. What is happening? Well, what I'm telling Node.js to do is I'm telling it that I want to read a file. I'm also telling it, I don't know how big this file is. I don't know how long this is going to take. So I want you to do that asynchronously. And that means read the file. And once that operation of reading the file is done, or Node.js figures out that there is an error of some sort, then you should call my function. And the function that I want you to call is read file done, and that is the function I've defined at the top here. So Node.js will read my file, it will put the whole thing into memory, and once it has done that, it will call read file done. If there was an error during reading, then it will pass the error in the error argument for my function. If there was no error, then it will put the file content in the data parameter of my function. Yeah, and so this should work if I didn't make any mistakes. So let's save this and see what happens. There. Now, there's 2 things that you should notice in the console here. 2 very annoying things. Well, they're actually good. They're intended, but they're still annoying. The first is that the time went down again. I'm back to 0.6. So where did this 7 point whatever? We know it takes more time to read a file. Yeah. So I'm not seeing that anymore. It's gone. And the second thing is that first it writes out the time, and then it writes out the content of my file. So these things are in the opposite order of what happened when I did this synchronously. And of course, if you think about what I said before, this matches exactly what I said before. I am doing a read file call, but I'm not waiting around for the result. I'm telling Node.js, you get back to me when you're done. So I'm doing the read file call on line 20, and then I immediately go to line 21, and I'm writing out this timestamp. And then whenever Node.js is done, it will come back and call my function. And so that happens much later. So the time I have in my timestamp is a lot lower because I'm not waiting around until the file was read. And the message with the content of the file comes behind here as well because I wasn't waiting around. So it's very logical what happens. However, you can see that it looks a little bit more messy because, well, I need to have a function and then so on. And then there will be some logic implications as well. Now, before I tell you what the logic implication is, I want to show you how you're probably going to see this in real life, because there are very few people that make a separate function and then pass the name to that function. What I can do instead is, instead of doing that here, give myself a little bit of place, I'm going to define the function in my function call. So I'm going to say, I want a function with an arrow and a data parameter. And I'm going to make this an arrow function. Yeah, so this is a shorthand way of writing that. And then I can just copy all the contents and put that in there, and I can delete the external function. So let's clean this up a little bit. There. This is exactly the same as what I had before. The only difference is that I am not defining my function separately. I am defining it inside of my read file call, and I'm using this shorthand arrow notation. And yes, if we have JavaScript experts saying that it's exactly the same is a lie. There are some subtle differences, but we can ignore them for now. That's not going to get us in trouble at any time soon. So this is exactly the same what I had before. And the logic is still the same. I'm still telling Node.js, read this file and come back to me and call this function, which is now defined as part of my function call. Call this when you're done, and either report the error or the content of the file. Now, what is the logic problem? Well, the logic problem, of course, starts when you want to do something with the content of that file. That's when it becomes tricky, because I have my application here. I have read this file, and now the logical thing that you are going to do if you start playing with asynchronous programming is that I want to now do something with it. So I could do this. I don't know what I have to write. I mean, yeah, I could, maybe data exists here. I don't know. The problem is I can't do anything with the result of this read file call at this level. The only place where I have the result of the read call is here inside of this callback function. And you could say, well, oh, that's not too bad. Then I'll just deal with it here. I mean, yeah, no worries. Okay, so now I want to read two files, and then I want to do something with the result of both. Where do I do that? Well, unfortunately, it would mean that you have to put that inside of this callback function. And if I ask Prettier to clean that up a little bit, then it looks like this. So I have read file. When it's done, it's going to call my callback function. And when that callback function was successful, I want to do the second read file. And then I want to do something with the result of these two, which I would need to do here. Yeah. Now, at this point, you're thinking that I'm pulling your leg, because that never happens in practice, but it happens all the time. That's the problem. It happens all the time. Maybe not with files, but imagine a database. I want to pull information about a job from a database. That information contains a user ID, and then I want to call the user ID from the database and get the information for the user. There, that's exactly the same thing. And it's even worse, because my connection to the database in the first place is probably also asynchronous. So now I have three callbacks that are nested in each other, and it becomes a nightmare. So much that there is an official term for it, and it's callback hell. So it works. You can use this if you want to, but it has some problems with it. And in some cases, it will not be an issue. And in my presentation that I made, I gave an example. Let's say that you want to write a whole bunch of synchronous code, and then at certain levels in that code, you want to do a log call to log what is happening. Well, you can do that asynchronously, and the logging will happen in its own time whenever the database is ready, and you just continue with the application. So that is an example of where using a callback like this is not going to cause any problem. But in situations where you want to do something and then you use the result of what you've done to do something else, that becomes difficult because of the how you work with callbacks. Okay, you get the drift. So let's see how we're going to improve this, because this obviously is very, very annoying. So let's get rid of this and forget about it as quickly as possible. It should be, I should mention that I'm saying forget about this as quickly as possible. You don't always have the choice. If you want to work with a library and that library is only using callbacks to do things, then you're kind of stuck with that. Yeah. So it's worthwhile to also, before you start using a library, if you have alternatives, it's worthwhile looking at what technique they use for asynchronous processing, if you have the choice. Okay, so I'm going to do something that really requires asynchronous programming, and where we see some timings as well to do the next bit. And in order to do that, I want to install an additional module, and that module is called Axios, and it is something that is used to do network calls. So you can do a get call to get a web page, but typically it's used to do API calls and so on. And it's relatively simple to use. So same way, I'm going to do const Axios require Axios. However, if I run this, so if I do save and I let nodemon run it again, my application crashes this time. Why? Because Axios is not part of the built-in modules of Node.js. It is actually a module that you have to install. Yeah. And we can do that quite easily. I don't want to stop nodemon here in this case, so I'm going to ask Visual Studio to give me another terminal that I can play with. So I'm again in my session 8 folder, and it is easy to ask npm to install this Axios module for us. There, so it installed some stuff. And let's go back to my other one. So now when I do save, it doesn't do anything because we haven't written any code, but it doesn't crash anymore. We have the Axios module installed, so we can get going. How do we use that? Well, Axios lets you do network calls, and that means you can do a get, a post, a put, all the different things that you normally use while making calls to APIs. And I'm going to steal my time stuff again, and we'll say start. Well, we'll just call it get call, and then I need to use the same string in both cases, and that should give me a timer again. There we go. So I want to do a get call, and I'll just get the information from my own website. So we're going to say const results equals Axios, and it's a really easy one, get, and then the URL. HTTP, yes, if I could type, that would be so much better. And I'm just going to get the homepage of the 4P's website for this. So there we go.
No? I think it's HTTPS to get to the homepage.
It will work in both cases, I think.
Okay.
It's actually relatively forgiving. So I'm going to do this. And then, of course, I want to see what the result is. So I'm going to print the result. We know how to do that, luckily. So take a guess what is going to happen, and it's probably not what you expect. Now, that doesn't look like a website. Yeah. So what it writes out is promise pending. Yeah. That's not what we expected. Why do we get this? Well, we get this because the Axios library doesn't work with callbacks, but it is a library that by default uses a next level asynchronous processing paradigm. And that is based on promises. And that is why it writes out promise. If I do this Axios call, the result thing that I get is a promise. What is a promise? It's a concept as a physicist I like a lot because it resembles the Schrödinger cat. A promise is Node.js telling you, I will get you an answer, but I don't have it yet. Yeah? That's why it writes out promise pending. It's a promise object, and it is in a state called pending. And that means that Node.js knows that it should give you something, but it doesn't know whether that's going to succeed or not, and it certainly hasn't done it. So it's a pending promise. In physicist terms, this is Schrödinger's cat, which is both dead and alive at the same time, and you don't know until you look. Same here, this is a promise, I will do it, but we don't know yet what the result is going to be. Now, obviously, writing out this promise is not very useful. This is not what I want to see. What I want to see is the actual content of my web page. So how do we deal with that? Well, there must be a reason why it gives back a promise. And the reason is that I can now use that promise and I can say result then, and I need to give that a function again. We're starting with functions. It looked good for a minute, but now it's going downhill again. And I am going to remove this and I'm going to add it into my callback, and that should be data. This is starting to look suspiciously much like what we've done before, yes? So if I save this and I did it correctly, there, it's thinking, oh, that's the web page. It looks better if you use Safari, by the way, but this is the code behind the web page. What just happened? Well, I'll do that again. I'll do save. Look at what happens in the at the window here for the console. So it says get call 0.6 milliseconds, and then it writes out, after a little bit, it writes out the content of the web page. So this is very similar to the system where you use callbacks, except that it is formulated a little bit different in the sense that I do a function call, this Axios get, that gets me a result object, and that is a promise. So if I want to be nice, I could call this promise. It's a bit iffy because the JavaScript class is also called promise, just with a capital P. So maybe promise is with a small p as a variable is, I wouldn't do that in practice, but I'm going to remove it in a second anyway, so it's not too bad. So I get a promise object, and that promise object I can then ask, give me the result. And I still, in that case, need to give a callback. And I can improve on that a little bit because now I'm not doing much error handling. I can improve on it by adding another function at the end. And this one is going to receive an error. So there. And let's reformat there. Okay. Yeah. So same concept. I'm telling this promise, if everything went well, then do line 35. If an error occurred, it is automatically going to be this catch line that is going to be run, and then I have a callback that handles the error. Again, you will probably not see this written in this way because I don't really need this promise object. I don't need to save it. I can just do Axios get and then connect the dot here at the end of my function call, and Prettier will reformat that by saying Axios, do my get call. If that is okay, then do something. If there is an error, then call catch. Now, I still have a little problem with program logic, meaning in my main application here, I still don't have the data that comes from this API from the website. I still need to go into a callback and write the rest of the code there. So you could very well wonder whether using promises is a huge improvement. I don't think so in most cases, except that some very, very, very nice gentleman, I think it is a gentleman, I'm not sure actually who invented it, came up with what they call syntactical sugar on top of promises. And that is something that makes your life a lot easier. So now we're getting to something that, that is easy to use. So I have this call here where I get a promise back. Well, Node.js also supports something that is called Async Await. And those are two keywords. There is one keyword called async. There is another one called await. And you can use them to basically convert asynchronous calls into synchronous calls. Joy. How does that work? Well, we'll run into a little snag here, and I'll show you how to get around that. But it's not that much more complex. So I'm going to remove all of this, and I'm just going to keep the Axios get call. And then I'm going to say result is await Axios get. You can see that this gets colored differently by Visual Studio Code. So it is actually a keyword, an existing keyword. And the purpose of await is when you use it with an asynchronous call that normally would give you back a promise and cause all kinds of headaches. Yeah. In this particular case, it will convert it into a synchronous call. And instead of having to write .then and a callback, I'll simply get the result of what I'm looking for in my variable, as you would expect it in a synchronous call. There's one small problem. And I will save and run this code to show you what it is. There. What does it say? Syntax error. Await is only valid in an async function. I said there are two keywords, async and await. And the truth is, they work together. Yeah? Behind the scenes, they set up an environment to convert asynchronous calls into synchronous calls. And in my example, I only have an await call. I don't have an async call. So if we want to do this in a Node.js application at the highest level, we have to do a little bit of trickery. And the trickery is not that difficult. I'm going to define a function. I'll use the very good name doStuff. And then once I've defined it, I'm going to say do stuff. Yeah. So what does this do? Well, stuff, obviously. So it defines a function and then it runs it. And now I can move this thing in there. And if I run this, I still get the same problem. But now I have a way of fixing it. How? Well, my await call needs to be in an async function. Well, I have a function, it's just not async. So let's make it async. There. And let's run this again. There. Now it works. Yeah. So what have I done here? Well, let's log. I was using info. I'm going to be consistent. That'll be first. So I'm going to do this again. There. Let me do that again and watch what happens. You'll see that it first writes out the timestamp. Now, that's the timestamp. And now it gives me the printout that I do. Yeah. This is a little bit tricky what happens here, but basically I was able to, in this function, I can now do these things one after the other, and I can use the result of all of them. Yeah. So by making my function async and by having this await thing in there, I don't have to use or care about promises anymore. I can simply start using the result immediately afterwards. And you see that there are no callbacks involved in this. what you have here on line 34 and 35, there is no callback involved. I just do my call and I get on with life. If I want to do this 3 times, that's not going to work. So let's just do it 3 times here. And I want to time this accurately. So let's move these things in there. And I'm not going to write it out so that it's easier to follow. Is that going to work, or did I miss something? We'll see. It's thinking. Yeah. I knew I was doing something that was not right. You can't assign something to a constant variable, can you? That's why it's called const. There. So this took us 7.6 seconds. Yeah. But what I could now do is I could have 3 different websites, 3 different calls. Let's assume this is an API. I can do 3 different calls, store it in 3 different variables, and then do something with all of these 3 different results. Yeah, I don't have to mess with callbacks. There are no promises in sight. They are nicely behind the scenes. So this is going to work just fine. So if you have a library, an Node.js module that works with promises, then you can use this async await system, these keywords, to convert that asynchronous system into something that is synchronous, and you can put away the headaches. Is this actually relevant in practice? Hell yes. Very much so. This is something that you will run into if you start doing anything with websites, APIs, databases, or like I said before, Switch. If you look at the new Switch scripting API that is based on Node.js, and you look at for example, the job get private data function, or any of the functions that is defined in there that gets information from Switch and so on, you'll see that in all of the examples and so on, they use async await there as well, because basically these things are all asynchronous. And now you could wonder, well, so what you're telling us is that there is no real point in doing asynchronous stuff, and we should just forget about it. Well, unfortunately, in many real-world situations, that is probably the best thing that you can do. But there are, of course, reasons that asynchronous processing was invented. And let me see. I have another 9 minutes, I think, before the hour is over. So let me see if I can make that clear. I'm going to rename this to do stuff sync. And then we're going to give ourselves something else to play with. And that we are going to call do stuff async. And actually, I don't really need a function for, I do need a function for that. Yes, that's right. So I'm going to do this, but of course I don't want to do the same thing twice. And I probably need to specify that this is async. This is going to be async, and the other one is going to be sync. Fine. So what I want to do is use this asynchronous behavior to get an advantage. What advantage? Well, I'm doing 3 relatively lengthy tasks. The 3 together are take time. Yeah. So I'm doing 3 relatively lengthy tasks, and what I want to do is see what happens if I do that a little bit differently, and I try to put them in parallel. How do we do that? Well, we use promises. So I'm going to do away, no, I'm not going to do away with that. I'm going to do away with the await thingies. So we're not going to use this trickery. Instead, I'm going to use promises. So this is promise 1. And then I'm going to be very lazy and do copy paste as much as possible. So there. I'm doing 3 calls. Of course, in reality, that would probably be different calls, but it doesn't matter for this example. I'm doing 3 calls, and each of these calls gives me a promise. I remember this promise object is something that is in a pending state when you immediately execute it, and then at some point it will give you an answer. And I want to do something with all of these 3 things together. So I need to have the result of all 3 of these in order to well, do what I want to do. How do I do that? Well, there is something that is really cool. I can do await promise. Promise is a class. It's a class that has all kinds of nice functionality. And one of these functions is all. And what does that take? All takes an array with promises. So promise 1, null. Okay, there, I will copy it. So I can make an array that has all 3 of my promises in it. So await promise.all, I pass an array with all the 3 promises that are the result of my calls here. And then at the end of that, what do I need to do? Well, I don't need to do anything. I'm just going to wait until all of them are done, I think. Yes, yes. I prepared this, of course, so I'm seeing how many mistakes I'm making. So there. So let's see what happens. Did we forget something, or is it okay? Yeah, so this by itself is a little bit weird. I'm getting them in the wrong order, but there is nothing wrong with that. I'm doing asynchronous programming, so things don't always appear in the order that you would expect. But what you can see here is that when I called this 4Ps website 3 times in a row, the total processing time, this is the synchronous bits, is 6.8 seconds. This takes 6.8 seconds. This second block that I have, that also reads the 4Ps website 3 times, takes 2.6 seconds. That is why you do asynchronous programming sometimes. Because what happens? Well, the first bit is synchronous. So I read it, I wait until it's done, then I read it again, I wait until it's done, then I read it again. Sorry, I pressed the wrong key there. Then I read it again. So I basically get end to end 3 times the same operation. What do I do here? This uses asynchronous processing completely. So I launch the requests, and then I immediately go to the next line. I launch the second request, and then I launch the third request. Yeah? These 3 requests to the web server run in parallel. And then the statement I have at the end says, now wait until all 3 of these promises have been fulfilled. So I have the result of all 3 of them, and then you can go on. And that's why I use the await statement in front of this. So when I come here, I actually have the result of all 3 of these calls, and I can go on. But because they run in parallel, the total time is much less. Is this relevant, and do you need to care about this? I'm going to make a bold statement, and I'm going to say that if you write small stuff, you probably don't need to care about it. Yeah. And the best thing you can do, trust me, I've tried both. The best thing you can do is probably not worry about it and simply use async await as much as you can get away with and forget about all the asynchronous stuff. Yeah. You just know what this async await means now when you see it, for example, in your in the Switch API. But then you can forget about asynchronous processing, and everything is synchronous. One thing happens after another. It's very logical. Life is good. Yeah. If you start doing things that are more complex, then knowing that there is something like asynchronous processing and promises, and that you can take advantage of that to have Node.js do things in parallel, might be a real time saver. Because look at it however way you want, but I was able to cut my processing time of something that is essentially the same in 3. This is 1/3 of what the first variant does. Yeah? And so if in switch, for example, you see this get private data call or any of the other calls that is asynchronous, and where in the examples you see them use async await, realize that that means that you could run these things asynchronously, and that means that you could run them in parallel to some extent. Yeah? There are some limitations. For example, Node.js runs things in parallel, but it has, by default, it has a fixed number of slots to run things in parallel. I believe the number is 4. I would have to Google it again, but I think the number of parallel slots by default is 4. That would mean that if I do this again with another website, I would probably get still a significant decrease, because they can all 4 run in parallel. If I would do it 5 times or 6 times and I go over that limit, then I might not see that much difference anymore, because things start to be scheduled one after the other there as well, because there are no more parallel slots available. You can change the number of parallel slots in Node.js, but you also have to take into account what you have on your machine and how many processors and cores and so on. So there are always limits that you're going to run into. Also, be aware that it's not because I connect 20 times to the same web server or to switch that I'm going to get the answer 20 times quicker. It might be that there are limits imposed on the other side as well. In databases, for example, you typically have a connection limit. Yeah? And if you overrun the connection limit, you're going to be waiting in line just as you would if it were synchronous calls. But at least knowing that there is something like asynchronous processing, and knowing that you can use promises to deal with it if you want asynchronous behavior, and that you can use async await if you don't want it and you basically want to have a life and do something simple, that I think is what you should remember from this, this cafe. And now it's 5 exactly, and I'm going to stop talking. So, any questions?
Yeah, so if you wanted to go beyond your limit and still have everything in line, you could sort of chain the promises together, right? Like get the first 3, and then when you have the first 3, then call the other 3. Then when you have all 6, do whatever.
Right. Yeah. You can chain together. You can also do clever things with error handling in that chain. So you could do error handlings at different times in the chain. You could say that you want to do error handling only when everything is done. So these promises offer a lot more capabilities than what I've been able to show in a short time here. And if you look for promise in the documentation, then you'll see a description of all the possibilities that they have, like the all function that I used here. I'm also not doing proper error handling in this case, and so on. So you do have to be very careful on how you deal with these things. Yeah, and that is also going to be the same when you're using async and await. When you get a promise, the promise can either be fulfilled or it can be rejected. Fulfilled means, yay, I was successful. Rejected means you lose. I wasn't able to do that. And then you can handle it. If you use async await, you will have to see what the way is that that particular library wants you to deal with that. And sometimes you get, the answer you get is, in some cases, you get a data object, or your result has a data property, and in other cases, it won't have a data property, and it will have an error property because something went wrong. And if you don't check for that, then you're going to crash. So async await is not a magic cure for everything. It just can make it easier to deal with asynchronous stuff, because it basically hides the asynchronous stuff that goes on.